So rational expressions are really just fractions. But, when we start talking about rational expressions with polynomials, we're just looking at fractions that are a little bit more interesting looking. And the thing that's nice about this, if you like fractions, is that all the fraction rules apply. And really what we're doing when we're dealing with rational expressions with polynomials, we are taking two skills that we already know. We already should know everything we would want to know about fractions, and we also know how to do factoring. And those are the two big skills that we need to use rather, to simplify rational expressions with polynomials. The interesting thing about this is there's really nothing other than that. We're just taking those two things and putting them together. So I want to do just a quick little review, and there is one new sort of topic that I'm going to introduce here. You won't see a lot of it in this class after that, but you will definitely see it in the next class, so I want to make sure that you are familiar with it. So as we look at this, the idea of any number over itself is 1, and we have seen that so many times, and we know, for instance, 3 over 3 is 1, and of course we also have to remember that stuff like this is also 1, exactly the same top and bottom. The other thing that we want to remember is, certainly when we talked about order of operations, we remember that when we look at the numerator and the denominator, we have to remember that there's an implied parentheses around everything in the numerator and everything in the denominator, so they pretty much have to stick together. So we need to keep that in mind. The next idea, so this is the idea of, just 1 and how we can see it differently. Then the next idea is the idea of opposites. And I have an example here, and the best example we have, of course, is 3 and -3 are hopefully obviously opposites of each other. Now the next one that I want to sort of look at is x plus 2. And what is the opposite of x plus 2? And the opposite is going to have to we have to make sure that every term is opposite. So the opposite of x plus 2 is -x minus 2. If you have x minus 2, this is not an opposite. It's a perfectly lovely little polynomial, but it's not the opposite of x plus 2. So you've got to make sure when you're looking at these opposites that everything is an opposite, not just one term. So in this case where the opposite, positive 2, -2, but both of these have a positive x, so they're not opposites. So keep that in mind as we sort of work through these. The next idea is the idea of -1. And we can do the same sort of thing that we had with the any number over itself. The difference here is that it's any number over itself, but it's opposites over each other. So when we talk about that, we might say something like -3 over 3. So we see that we've got opposites, and that's going to get me my negative. But then there's that 3 over 3 here, and that gets me the 1. So that's how we can get a nice -1. Now the same thing is going to happen here. Like, let's say that you've got let's do x minus 2. And remember, when we're dealing with opposites on polynomials, everything in the polynomial has to be opposite. So that would mean that this would be a positive 2, and the x would be a -x. And we could rewrite this if we want to say x minus 2, 2 minus x, just so it looks a little bit prettier. Either way, they're -1. So opposites give us that -1. Opposites over each other give us that -1. So now we want to just mention a couple other little ideas, and we're going to talk about zeros. And they're called zeros in classes later on, so that's how I sort of refer to them periodically in this class, just so you sort of are familiar with the idea. A couple things to remember is that, I can't remember when we first talked about it, but I know we've talked about it in this class, and probably not as recently as I would like, and that's why I want to mention it again. So here we've got division properties of 0. this is probably one of the first couple days of class, certainly within the first week of class. So 0 over 16, we know that 0 on the top gives us 0, that's okay. And then we have the 16 over 0, that's the undefined. And remember, the idea is when it's undefined, we cannot divide by 0. It's something we can't do in our number system. So again, we can't have 0 in our denominator because it makes the fraction undefined. Now, we've got polynomials now, which are more complex, so we have to look at them also. And this is where it starts to, we start talking about it in sort of a different context, and that is the context of what is domain. And the domain is determined by the denominator in rational expressions. And it's the set of numbers for which that rational expression will work, or is defined, thinking of the undefined things that we have to get rid of. So when we talk about the domain, we basically start out with a set of all real numbers, and then we have to find the exception to that set. And we find that exception in this case by looking for the things that make this rational expression undefined. So what makes the bottom 0? Those are the things that we can't have. So hopefully, let's go ahead and just do a nice little example here. So the first thing that we do is we look at this nice polynomial over a polynomial. So there's our rational expression. X minus 3 can't be factored, but x squared plus x minus 12, that can be factored. So that's a trinomial with a leading coefficient of 1. So we know that's a double parentheses. And the leading coefficient of 1 means it's x and x. And then we look for the factors of 12 that subtract to 1. So hopefully we can see that that's a 3 and a 4. And the second sign again tells us the signs are different. The bigger product gets the plus. So there's my plus and there's my minus. We also want to remember, of course, going back to the idea of order of operations, that everything in the numerator has to be stuck together. So sometimes it's handy to go ahead and put that in parentheses so you can really see it. And now this hopefully lets us see very clearly that we've got an x minus 3 over an x minus 3, and that those are the things that are exactly the same, and so can be canceled out. So we have, first, we've factored out everything that can be factored. And then we can see that we can simplify it. Now, what we want to do, though, is I want to just take a little step back here, because that's not dealing with undefined. That's just showing you where we're going with it, because this is really important. I'm going to put the 1 there, because we'll need that later on. But this is where we're going to go with it. What we want to do right now is just talk about this idea of undefined. So we're going to go ahead and determine where this expression is undefined. And what we do is we take everything that's in the denominator. So that would be x minus 3 and x plus 4. And we're going back to that idea of the zero products principle. If the bottom, we're trying to figure out where the bottom is equal to 0, we're basically saying if one of these two factors, x minus 3 or x plus 4, is equal to 0, then the bottom will be equal to 0. So those are the two things that will make it undefined. So we do the same thing that we did when we solved equation. We're just doing it for a different purpose. So we set them equal to 0, and we solve. So in this case, it's x is equal to 3, and in this case, it's x is equal to negative 4. So after we got that, forgot to rewrite this, we now see that this polynomial that we started out with is undefined at negative 4 and 3. So let's just do a couple little quick examples of this idea of undefined. So again, the first thing that we do is we look at it and look at our rational expression, and we see what can be factored. Now the numerator can't be factored. I'm going to go ahead and put it in parentheses so we don't forget that it has to go together. And then I'm going to go ahead and factor the denominator. And of course that's x and x. And we're looking at the factors of 6 that subtract to 1. So again, that's 3 and 2. Signs are different. Bigger product is negative. Then we look to see if there's anything that's the same top and bottom, and that's how we go ahead and simplify. But right now we're talking about undefined, so we're just looking at the stuff that's in the bottom, or on the bottom, and we take each one of those, set them equal to 0, and solve. And that is going to tell us where this polynomial is undefined. So it's undefined at -2 and 3. So let's go ahead and take a look at this next one. Again, we see if we can factor anything. The numerator in this case can be factored. We've got a greatest common factor there. So we take that out. When we take that out, we're left with x minus 2. And then the bottom has the 3x. So again, remember that it doesn't matter what's in the numerator. All that matters is what's in the denominator. So we take whatever's in the denominator, whatever factors are in the denominator, we set them equal to 0. In this case, we only have the 1, really. We divide that by 3, and we're left with x is equal to 0. So this polynomial is undefined when x is equal to 0.